Hi, my name's Harry. Welcome to Weld and Fabrication. Today we're going to be looking at plug welding and the benefits of this as well. So what I've done is I've made up two skins of material just to simulate, or it could be you're doing a repair, it could be for body work or body panel, it could be down to access, so you might only have access on one side. And what we've done is I've used a Whitney punch, which I've got set up with a 5mm punch in, punched a series of holes through the piece of material on one face, and then by sandwiching it to another piece of material, laying it onto another piece of material and clamping it on, what we've effectively got then is we've got a void there that we're going to plug, i.e. fill up with weld. The advantage of doing it this way is, again, it could be down to access, it could also be down to the amount of distortion. By plug welding rather than fully welding, it enables us to create a good strong weld that can penetrate, but also at the same time reduces the amount of distortion we get over the whole panel. And when we start looking at things like thin gauge material, this is going to be a major advantage, especially with stuff like car bodies, where obviously where you get the distortion, afterwards potentially you're going to have to sand it back and maybe fill it to try and get rid of any ripples or any surface distortion on the material. So the machine we're using, basically what we're going to be setting up is approximately about 19.5 volts, and we're going to have it on between 90 and 100 amps, wire feed on 6 meters per minute. Gas, so our gas on, we're going to have our gas set on approximately 12 to 14 litres per minute. And what we're going to do, I'm going to show you how to use what we call the spot welder function. So on the front of the machine here, you can count it out, arguably, if you haven't got this function, but we've got what's called a spot weld function or a timer function on here. So I'm going to set that 1.5 seconds. So basically what that means is when I arc up, onto the face of the material, the arc will establish itself and it will maintain itself for 1.5 seconds, and then it will go out. So it gives you a short, controlled burst of energy. The idea of this is that if you're plug welding, so if you have a series of holes that you're going to be filling up, it enables you to keep them consistent. So it's the same time frame every time. You've set the current and voltage, so that's all going to be set up correctly. So as a result, you should end up with, technically, depending on arc length as well, obviously that will help, that will change the variables, but you should end up with a reasonably consistent spot weld. So we're going to use 0.8 wire for this particular sort of spot welding I'm doing today. If you're doing a lot of very thin gauge material, the likelihood is you'd probably use 0.6. You'd be dropping down, especially if you're working on 1.6 material. 0.6 would give you much more control over the amount of heat input you'd be putting into the material as well. So, turn the machine on, gas is on, just quickly check. Yeah, gas is good. Okay, so what we're going to do is line the seals up over the hole, like so, and line your eyes, right, okay. You might find that if you want to have good contact, you clip your wire each time, make sure that you pull it through. You will get a little bit of slack potentially in the liner, so that little bit of slack there you can pull through on the torch. And we go again. Line your eyes. And again. And again. And again. So each one of those spot welds has been done at the same current range, approximately, say, 100 amps, about 19 a bit on the volts, and we can see there that uniform wise they're reasonably consistent, and on the back there you can see they're just starting to penetrate through, but the amount of penetration you're getting right the way through that panel is consistent as well. So if you're thinking it's slightly too much, that's fine, depends upon obviously your arc length. Could be you either come down on the time ever so slightly to reduce the amount of penetration you're going to get, or alternatively, what you might also do is you might also increase or decrease the current range you're going to be welding at as well. Okay, what I want to look at next is I want to have a look at doing the same principle, but we're going to do it in TIG instead. Right, what we're going to do this time around is, rather than using the MIG, we're going to look at the TIG, and we're going to look at plug welding the holes up using the TIG process instead. What I would say is that in terms of plug welding the holes, it's quite important to take into consideration that the amount of heat you're going to put in, it's going to be a little bit less. We can control, or we can direct the heat much more so with TIG. So we're going to go in about 60 amps. In terms of filler wire, we'll use a 1.6 filler, little tiny dab of filler wire in there just to help it fuse and fill the hole up as we arc up. We want to make sure we use a triply oxidised filler wire just to reduce the chances of getting any porosity within the weld pool as well. And also, in addition to that, I'm using the slope out function. So on here we've got slope out function. I'm set that about 1.5 seconds. And what effectively I'll do is, as the molten pool starts to solidify, rather than just taking your finger off the trigger, holding for your post gas, and all of a sudden your molten pool's nipping up, it's going to contract over 1.5 seconds, so reduce the chances of getting things like crater pipes, those holes in the centre of the weld. Post gas, we've got set on about 4 to 5 seconds, and our gas flow rate is 6 to 8 litres per minute. So we're pretty much set up in terms of what we're going to be doing. So the only thing we need to take into consideration is that, unlike with the MIG, where we had a timer switch on this time round, all I'm looking for, as soon as as soon as that fuses, take my finger off the trigger and stop it. The advantages of using TIG over MIG, for instance, would be that if you're working, could be on a restoration project, you haven't been able to fully strip the vehicle out, like for instance something like an old VW split screen camper, something like that. It means that if you were putting in a new window surround or putting in a trim like that, for instance, you wouldn't necessarily have to strip the whole vehicle out because there's no sparks. You still have to, obviously, within the vicinity of where you're welding, strip that area out. But in terms of fully stripping everything out, not necessarily necessary, because the sparks aren't going to travel. It's very localised within the area of where you're welding. Okay, so just turn the machine on. So I've got it set at 60 amps. Using a water-cooled torch. So quite a small compact torch. Got a short backing cap just to give me better access if I was working in a sort of more of a confined area. I'm using the number 7 ceramic nozzle. I've got a 2.4 seriated tungsten, could use a thoriated, and I'm using a gas lens as well. Okay, so let's fill the wire up. So I'm on about 60 amps. So what I'm going to do is I'll just do 5 plug welds here. Do these quickly. Mind your eyes. Hold for post gas. Right, okay. The only thing I would take into consideration is that last one I put in there, you can see I didn't move the clamp right to the end. You can see the gaps just opened up where I didn't fully press it down on the end there. And you can see I've had to travel just a little bit further. So it's much less forgiving if your setup and your prep isn't good with TIG. Whereas MIG, you tend to be able to fill it quite quickly. With TIG, you'll find that it will melt the material and run away from you quite quickly, and you'll end up blowing a hole through. Size-wise, obviously, they're much flatter in profile. You can see they're much flatter in profile in terms of the difference between the two. I would also say, obviously, the amount of penetration. Equally, you've got a little bit of suck back on a couple of these where, let's say, towards the end there we had a little bit of a gap, but it's about the same amount in terms of penetration. They're both, we're going to have no issues in terms of fusion whatsoever. So there's a couple of the options in terms of what you might want to do, and obviously the amount of distortion you're going to get, and that's the key thing, is that when we look down a piece of material there like so, you can still see it's nice and straight because we've managed to spread the heat out over small localised areas. As a result, we haven't got a huge amount of distortion and warping of that parent material. So if you're doing something like say an internal panel on a vehicle, it could be a wing, could be rather than having a bolt-on wing, you've got to drill the plug welds out and then you've got to plug weld it back on. It could be that if you can't even buy the part for the vehicle, it could be you're just doing a small repair and you find you've got to patch something in. It might be that you decide to plug weld it rather than fully weld it. It just depends upon, obviously, things like seals need to be fully welded in certain areas. But it could be on panel types, you might be able to plug weld it to reduce the amount of distortion you're going to get, and then all you've got to do is flush back the tops of the plug welds after. Again, it could be access, something like that. Okay, thank you very much.